Hello everyone, welcome to our next session of Arduino, that is Arduino 2, which we will be making today, a thermometer. So we are using this special sensor to make a thermometer. Okay, let's see how it works. So you remember when you were kids, or even now, your parents used to measure your body temperature by keeping their hand like this, right? But it's not an exact measure. So they are using this glass tube like a thermometer, which is given here as a picture. So you put it in your mouth and get the temperature. So but that has to be sterilized every time you use it, right? Because you put it in your mouth, and in your mouth there's a lot of germs. So you have to put it in hot water and sterilize it. So that is a bit of a hassle, right? And it also doesn't give you exact measures. It's not that accurate. So we are making an accurate thermometer using Arduino, right? Let's see how we're going to make it. Now turn an Arduino into thermometer. Now this Arduino using a TMP36 temperature sensor, which is this one, as you can see here. Using that, we're gonna make this thermometer. Now we have 3 LEDs to indicate 3 levels of temperatures. That means, let's say cold, warm, hot, things like that, right? So and the TMP36 temperature sensor gathers the temperature readings. Now these are the things we need. We need an Arduino Uno board and a cable and 3 LEDs and also 3 resistors to resistors and TMP36 sensor and a breadboard. Now what is this TMP36 temperature sensor? It is a temperature sensor which changes the output voltage according to the temperature which it is getting. So let's say it's like a regulator. Depending on the heat or the temperature it gets, it controls the output voltage. So it's like a LDR, but if you know about LDRs, LDR is a resistor, a light dependent resistor. So depending on the light level it gets, it reduces the electricity which flows through it. Now, so this is the TMP36 temperature sensor that we're going to use. Let's see how we're going to use it in our circuits. And these are the examples for many types of temperature sensors we are using in Arduino, right? You see, for many different users, we have many temperature sensors. We have one here like a rod, which is waterproof, and we have like a there are circuit parts which can be fitted into a circuit, right? So many type of sensors are there. So we are using this TMP36. Now how does it work is, when you simulate the circuit, we can't actually give directly heat into a simulated circuit. So what we have is a simulated part where we can control the temperature. I'll explain that even better in the simulation. Now, so these are the steps of building this circuit. First we build it in Tinkercad to simulate it, and then add the temperature sensor. After that, Arduino code, simulate and test. Analog input observation, I will explain that in the coming slides. Now yeah, so here our part, the analog input observation, what it means is the analog signals from TMP36. So the TMP36 is an analog device, right? It's giving out analog signals to the Arduino. Now there's this ADC, okay, analog to digital conversion. That is the part which converts these analog signals into digital signals. So it's like a translator, right? So I speak Chinese and you guys don't understand, so I get a translator. So the translator translates into English, let's say, right? So it's like that. Now as you can see, this is the pin out of the circuit. So we'll go. Now the sensor values pouring in. Now here yeah, in this one also I want to say, once you connected the temperature sensor, you can see in the serial monitor here. I will show you that in the simulation. In the serial monitor, the exact amount of heat it's getting, right, in Celsius and Fahrenheit, right? Now, so this is how it works. Let's see. And Arduino code, we are using Arduino text-based code for this program, and then we will be using Tinkercad to simulate this circuit. Okay, now we will get started. Okay, now you remember how we opened Tinkercad before, right? So this is the Tinkercad website. Please go to this website and browse to this website, and we will get started on the circuit building now. So I will go to this Tinkercad website right here, and if you go here, you can see okay. So here you go to this website, and then I go to sign in because I already have account, but you guys can even from the last session you must have the account, so you can directly sign in from here. Okay, so once you sign in, you go to the circuits category. I will tell you how to do that. Okay, so you select the account that you corrected last time, you fixed last time, and then you add the password. Okay, just give me a second. Okay, you browse to the Tinkercad. Once you sign in the way I told you, so you will be redirected to your dashboard, right? Guys, so as you can see here, I'm logged in. So once you logged in, you go to the dashboard, and once you are there, you go to circuits here under 3D design. So you go to circuits. This is the same way we did our last session, so you should remember now. Okay, now I'm going to create a new circuit. Now you see the green button here, create new circuit. You go to that. Now in this one we are going to create the simulation of the circuit. Okay, now the first thing that we want is the Arduino Uno board, right? So you get the Arduino Uno, and then so this will be easy for you guys because I have provided the document with the connections, right? So you can look at it if you don't see the connections clearly in the video. So under the our video name, there will be another link redirecting you to that document. So in that document, the code and the connections will be there. Okay, now I have added the Arduino, and now I'm going to add the breadboard, which is, you can always search for it also. You can scroll and find the component, that doesn't matter. Okay, now so I'm going to keep this parallelly. And what is the first thing that we need? The temperature sensor, right? So the temperature sensor, I'm going to keep it close to it because you can see the connections clearly. So you search for it as TMP36. Here we go. So this is the temperature sensor, and I'm going to keep it here. As you can see, the temperature sensor has 3 legs, so 3 connections can be made to it. Now here, the first connection is the middle leg. Here, V out, it says V out, and we're going to give it okay, we're going to give it to A0 port. Okay, you can see directly. Now that is our first connection. You follow me in this video and just do what I do in the follow the steps as I do. You pause the video and do it step by step so you can understand how the connections go. Next, the power. The power goes to the positive terminal of our breadboard, right? I'm going to keep it here. I'll put a different color for the wire so you can identify it easily, and this one I'll make it yellow. So that I'm using the same colors as your diagram, so you can't it will be less confusing for you. Now the third one is the ground, right? That means the negative one. So I am getting the negative one here and goes to the negative red. Now that will be black because negative is always black, right? It's just not related. You can use any color you want, but these colors will be better. Now your ground, so as the negative terminal, negative rail of your breadboard will be connected to the ground. Since this is also ground, connect it into ground. Now, so I am following the same steps as your diagram, so you can even see the same connections are there in the diagram, right? Now I will make it black because it's negative, and then the positive terminal will be connected to, that means the positive rail will be connected to the 5 volts. So that is where it's getting the power from. Okay. Now, okay, here we go. So since you have different colors, you can easily identify this. That's why I use different colors, but don't get it mixed up. Okay. Now, so that is done with our temperature sensor. Now we go for the LEDs and the 220 resistors. The resistors, why we are using a resistor in a circuit, right? So first I am getting LEDs. So this LED has a specific amount of electricity which it can take. We can't just directly connect the LED to the current in our house, no. It can only take a small amount of electricity, right? So I have added 3 LEDs here, which is red. I'm not going to change the color, but if you want, you can change it. And this LED, yeah, I was talking about the resistor. So the resistor can only take a small amount of electricity. So that's why there's a resistor to reduce that electricity and give to the LED. Okay. Now we'll add the resistors. Now as you can see here, the cathode or the negative terminal, we're going to connect the resistor to the negative terminal. To connect the resistor, I'm going to search for resistors here. Here we go. And then, okay, so I'm going to keep it here. I don't want to connect it with a wire, right? Because why? This whole rail, as you can see, the highlighted in green color, the whole rail is one rail. So if you connect it into that same rail in this green color, you can see that means it's one connection. So it's like a rail, right? That's why we call it same rail. So as you can see, in just like in a chessboard, it's numbered, so you can see which line you are connecting to, right? Now I'm going to connect the resistors leg into the negative terminal. So it's the same thing if you do it according to the diagram. Let's say as example I am doing this. Okay, directly connect it to the negative terminal and then connect in the okay, yeah, that's good, right? So this terminal is connected to one of the ends of the resistor and the second one is connected to the negative one. Now the resistor value is 220 ohm. So here you click on the resistor and you type the value 200 and then what is the symbol? Ohms, right? So 200 ohms. Now as you can see, the colors change. So if you click on it, it changes. Right. As you can see, if I change the values, it changes with it. The colors changes with it because the colors of the resistor, sorry, it's 220, right? Okay, sorry. Now 220. Now the colors of the resistor indicate the resistance value which is giving. So I'm going to duplicate the same one. I'm going to copy. I'm going to click on the resistor and then duplicate it, or you can also get another resistor and change the value, doesn't matter. I'll do it one more time that way. You get this resistor, gonna connect it here. As you can see, to the cathode I am connecting, okay, to the cathode of the LED I am connecting. Now changing the value to 220 ohms, right? The symbol is ohms. Now we are done with the resistors. Now the negative leg of the LEDs are connected, negative terminal of the LEDs are connected. The positive terminal of the LEDs, we are going to connect it like this. Now each of these connections has to be connected to different terminals of the different pins of the Arduino. Now I'm gonna connect the first one now. Now let's see here. If you connect it here, the first one will be, I'm getting the pin 2. I'm getting pin 2. As you can see in the diagram, I have connected the one in the left, the first one in the left to pin 4, right? Okay, so that is pin 4. Okay, and going above 3 and 2, right? Pin 3 and pin 2. I will use different colors. For now, I'll make all the connections. Okay, you can see when you're connecting, it shows which connection that you're doing, right? Okay, aligned properly, so you can easily identify it. We'll make it blue. I'll make it all green, so you know each of these connections are going to the LEDs. No, the color given in the diagram is blue, so it doesn't matter actually. Now that's it, right? These are the whole connections of ours. If you want, you can take more time in the circuit because it's in the diagram, so you can refer to the diagram and do. Okay, we'll start the code by first doing the variables, right? So we are doing the variables because we need 3 variables to store the values of our baseline target baseline temperature as well as the sensor values. So the first thing that you have to do is the baseline temperature. Now int baseline temp. Okay, now space 0 and that's it. Now for the second one is int celsius third one is int Fahrenheit. Okay, we are done with the variables. Now we will start with the void setup. Inside the setup, pins are configured using the pin mode function. That means we are talking about 3 to 4 pins here, 1 as input and 3 as outputs. As you can see here, 1 is connected to A0 in the analog inside A0 and it's leading to the temperature sensor, and the other 3 pins, they are leading to the LEDs. So that is the output, right? So it should give out a signal to the LED to light up. Okay, now we'll start. Void setup. Open and close the bracket. Open a curly bracket. So first one I am going to say pin mode A0 is a input, right? That is our first thing. All capital. This is a case sensitive language, so when you are using capital and simple, you have to be careful, right? Otherwise you get errors because of this. Then serial beginning, begin with 9600. Then okay, we declare the input pin. Now we're going to declare the pins which giving out the signals. That means the output pins, right? Pin mode 2 is a output. I will show you these pins. Okay, close and this. Okay, now we're going to repeat the same code for pin 3 and pin 4. Okay, we're going to repeat the same thing for pin mode 3 and pin mode 4. Those are the pins which is mentioned here, 2, 3, 4. You remember, right? We did it in circuit. Now pin mode 3 is also output. Pin mode 3 is also output. And also pin mode 3 as 4 same way is the output. Just remember, don't miss any letters or symbols. Okay, everything is very important when it comes to coding. If you even miss one semicolon, you get a big error in the code, right? Now, so we are done, and we're gonna close the curly bracket. Okay, now we are done with that. Now what we're gonna do is the void loop. So as I told you, we avoid setup codes only. We say tell it one time, it will run only one time, right? Void setup codes, which is inside the void setup. Now about these loops, void loop. Now void loop, what is the name? You remember when you remember the word, when you hear the word loop, what do you remember? Right? The hula hoops, the circles. So that's also loop, right? Now this one is called a loop because whatever you put inside this void loop runs several times, again and again it runs, right? So it's a loop. Now we will start with the void loop. So in here I have added the comments to your code because you can understand better what the code is about. Whatever it starts with this double dash, that means it's a comment, right? You remember this from the last session also, so I'm not going to tell that again. So whatever starts with double slashes, that means it's a comment. Now comments are for you to understand how the code works. Okay, so it's not those are non-executable things inside the code. Oh, sorry, it's supposed to be this, and then Celsius. So we're gonna start with 1, 2, 3, 4, right? Sorry, 3 brackets. Then we're gonna type analog read A0. You know this now because A0, as you know, is the pin that we talk about, right? A0, the input pin. So we're gonna close that bracket and then -20. I'll explain what is happening here. Okay, multiplied by, in computers this is the multiplying icon of the stuff, 3.04 close bracket and comma 0 comma 1023 and then comma -40. Don't worry about this being confusing, I'll explain. Okay, and then 125 then close brackets. Okay, and end it with a semicolon. Okay, so here I have added 3 brackets, right? So you can see here 2, 1, 2, 3 brackets are being closed. So whenever you open a bracket, that means you have to close it. So otherwise you get errors, right? Okay, now that is done. Let's see what's next. Okay, about this code, to activate LEDs. Now here, measure the temperature in Celsius. Okay, this one is to measure the temperature in Celsius. Okay, so this is the formula for that, and then the baseline 40. Okay, baseline 40 means the threshold temperature to activate the LEDs. The first temperature to activate the LED is 40. Right? Now, those are the meaning of these two codes. Now, let's see what the next one is. Okay, Fahrenheit. Fahrenheit also the same way. Sorry, simple. Fahrenheit, that also has a formula. So this is like a conversion from Fahrenheit to Celsius. 9 close bracket, this is just one slash, so it's not a comment. Remember, don't confuse. Plus mark 32 close the bracket, right? So Fahrenheit equal Celsius multiplied by 9, like that. Okay, let's see what's next. Serial print Celsius. Now serial print Celsius. Serial print Celsius means this will show the value of Celsius. This is the next code which I told you about. The next code is to print the value, that means show the value of the Celsius. Serial dot print. Serial dot print, open and close bracket, Celsius. Okay, and the next one is serial print dot print, serial dot print. So this is actually the symbol for Celsius. We're gonna put close the bracket. Serial print Fahrenheit. Okay, serial print. So the the meaning of the print means that it will show, right, somewhere. It will show somewhere. Print means that. If you ever use the word print, that means it will be shown somewhere. So this is a symbol for Fahrenheit, which is a F, right? Symbol for Fahrenheit, semicolon is added. Now, what is next? So now this is the formula for converting between Celsius and Fahrenheit, right? That's the formula that we added and print in the serial monitor. We print in this, that means showing this in the serial monitor helps you to observe the temperature changes more granularly. That means you can see the exact temperature. Now, Yeah, that's it about the thing. Now we'll go down. You go according to this code, okay? So I'm using the same code now. Okay, I will do this, do one and copy paste the rest. Now, if statement is there. Now, this one I have to explain before I do it. If the temperature is now, if you look at this formula, it's not that complex, but it looks big, no? So that's why I want to explain. If Celsius is less than baseline temperature, digital write to low. Okay, I will type this. Wait. If Celsius, that means if the Celsius amount is less than baseline temp, that means what should happen? I'm opening a bracket here. Digital write, every LED should stay turned off. That's what happens here. Okay, if the Celsius is less than baseline temperature, that's the last temperature level that we have. Okay, and if it is less than that, every LED should be turned off. Basically, we are telling that the one condition, right? If the temperature is less than the baseline temperature, every LED should stay turned off. Every LED should stay turned off. So that is not just one LED 2, right? LED which is connected to not only to pin 2, that is every LED. So I'm gonna trick here as also 3, again 4, right? So in here we say if the baseline temperature is less than Celsius, all LEDs should be turned off. Low means turned off. The brightness is very low, so you can't see. That means turned off. Okay, now next one is if the Celsius is greater than or equal to baseline temperature, first LED should light up, right? If Celsius value is greater than or equal to baseline temperature. If the Celsius value is less than greater than or equal to baseline temperature, the first LED only should light up. That's what we're gonna do. And Celsius is less than baseline temperature plus 10. Okay, this is a bit tricky part, but if you know mathematical formulas, you can understand this easily, right? Baseline temp plus 10. I'm going really slow so you guys can also see this, right? So you do it with me. Okay, if the Celsius value is greater than or equal to baseline temperature, here in this space, if the Celsius value is greater than or equal to baseline temperature, and then Celsius baseline temperature is plus 10. Okay, if it is greater than baseline temperature or equal to it, one LED should light up. So here same as this one. Okay, so you can understand better, I will get this same thing. Okay, only the first LED that we have to light up now. So what we are going to say, only the first one is high, HIGH. Got it? So it's pretty simple. If the Celsius value is greater than or equal to baseline temperature, what should happen? O less than and plus 10. One LED should light up. So that is the second condition of ours, right? That is the second condition. Then what we're going to say is about the second LED, right? Second LED also should be there. Now for the second LED, what we're going to do is, we're going to say, if the Celsius value is greater than or equal to baseline temperature, we're going to add 20, right? We're going to add 20 and say, light up both the LEDs. Okay, so here the same circuit code, the same code we are using. Okay, now Celsius is greater than equal, and we added a 10 here, right? Baseline plus. Okay, just give me a second, I'll just type it in. Now I want to explain is, now we are lighting up two LEDs next, right? So in the first one we have lighted up one LED which is coming from pin 2, that means this one, that is the last LED, right? Now next one is, if Celsius is greater than or equal to baseline temp and baseline temp plus 10 Celsius, plus 10 plus 10 baseline temp baseline temp plus 20. Okay, sorry, open a bracket, and then the LEDs we're gonna program. Keep them aligned so you can see better. First one is digital, right? As I explained, now we're gonna light up two LEDs, right? So two of these LEDs will be high, that means turned on. Okay, see, now the second condition is that we move on to the third condition. Yeah, before that we have to close the bracket, right? Unless if you open a bracket, we have to close it. If next condition is, we are adding 30, same code. Okay, I'm repeating the same code, so you guys also should be able to understand. It's the same code, just changing numbers in the code. Okay, if Celsius sorry, it should be in a bracket. If Celsius is greater than or equal to baseline temperature, plus 10, oh sorry, plus 20, Celsius is less than plus I'll use some spaces. You can look at it again. You can see it's the same code, we are just changing the numbers, right? We are just changing the numbers and adding the same code. Okay. So in this one, how many LEDs going to light up? Right, 3, right? Since it's the same code, just copy pasted it. Okay. So in this one, 3 LEDs are lighted up. And then we're gonna close the bracket. Right. Okay, the final one. If Celsius is less than or greater than or equal to baseline temperature plus 30. That's it. If Celsius is greater than or equal to baseline temp we should plus 30. Okay, it's just if you can read this, you can understand easily, right? You can read the code. It's in not that much hard to read, right? It's in simple English now. So this is the next one. I'm gonna say third one is all 3 LEDs are lighted up, and then we're gonna use the code from here. Then again a delay of 1000 milliseconds, that means 1 second, right? 1000 millisecond means 1 second. Okay, so this is the end of the code, but if you have any confusions or confusion, please go to the document and you can refer to that. Okay, after the delay of 1000 milliseconds, that means 1 second, we can finish the code by adding just another curly bracket. Okay, so I will explain from the top to the bottom again about our code. First, we have created 3 variables to store our values, and then we said about the pin modes. Okay, what are the pins? What are the jobs of our pins? A0 is an input pin, right? And then pin mode 2 means the second pin is output, and also the third and the fourth. And then we have said baseline temperature is 40, right? So this is a fixed value which we're going to use later, right? So Celsius equal to MAP. So this is our first code for the first LED, right? So this is a void loop, right? Then we said print the serial values of Celsius and Fahrenheit. Yeah, this is our first LED. So when the Celsius value is less than baseline temperature, that means 40, right? If it is less than baseline temperature, what should happen? All the LEDs should be turned off. And then the second one, if the you get the if the temperature level is more than or equal to baseline temperature, that means if it is more than 40 and baseline plus 10, that means let's say 50, okay? One LED should light up. So as the same way, second LED will light up, and in the third if condition, all the LEDs will light up, okay? And the last one is if not. Now, so this is our code. We'll see how it works in our simulation, right? So you can see here we have a start simulation button. If you click on that, it will start the simulation like that, right? So here I'm going to close the code, and now what you have to do is as you can see here, no errors are there, right? And here the serial monitor is there, so I'm going to turn that on, right? Now you click on the temperature sensor, something like this will appear, like a icon that you can drag. Okay, so currently as you can see, the temperature which is giving out of the sensor is 77, right? 25 Celsius and 77 Fahrenheit. Now I'm going to increase it a little bit. Let's see what happens. Okay, now the temperature increased, right? So the temperature with the temperature sensor has been increased. Now I'm going to okay, now you can't see the LED, so I'm going to close the code, right? So this is how the serial monitor works. It is giving out the exact amount of temperature which the temperature sensor is getting. I'm going to close the code, right? Now I'll show you how the simulator works. Now with the LEDs, right? Look at the LEDs. I'm going to increase it point by point. Okay, that's the second one. That's the third one, right? So that means if I increase it more, nothing will happen. It's only 3 LEDs and 3 numbers are there. I'll decrease it again. I have to do it slowly because it's very small. Okay, that's it. So these are the things which we explained in the code dose, right? So hope you guys enjoyed. This is the end of this session. Please refer to the document which we given for the connections of the circuit, right? The connections with the wires, and then also the code is there. You can simply put the code in the code, copy the code and put it here. But just to learn more, I prefer if you guys can type this, so then you can make mistakes and learn. And the serial monitor is here. If you guys want, if you click here, you can see the exact amount of temperature which the sensor is getting. See here. Now I'm going to close the serial monitor and stop the simulation. Okay guys, so this is the end of our session. Hope you guys enjoyed, and see you guys in our next session.